Just a quick demonstration of the whole system. Here we've got the front end user interface on the touchscreen. That front end is being served as a web server by this Raspberry Pi. And connected to this Raspberry Pi via an i2c bus is the Unity module. And now the reason it's called the Unity module is because every different type of module, it could be dispensers, mixers, gantry cart, anything, will have the same identical board with different programming. And over communication on the i2c bus, it'll determine its various functions and capabilities. The Arduino is just my programmer for the i2c Mega on this board, and it's just providing some power, so it's not really doing anything in the context of this circuit and won't be there in the final design. Attached to this Unity board, I've got a stepper here, which is being driven by the A4988 driver, and then just an auxiliary. I've got a switch here and a Hall effect sensor. So you can see when I push the switch, it turns this light red, and when I move to the magnet next to the Hall effect sensor, it starts it flashing. So both of these actions will, in the current programming, stop the rotation of the motor. So what I'm demonstrating right now is basically just the connection between the front end through the web server backend and the Python i2c on the Raspberry Pi, the connection with that and the i2c Mega on the Unity board. So what I'm doing is basically I'm going to control the speed of rotation of this servo using the protein dial. So it's at 0%. If I add some fat and carbs, whatever, and I click make my granola pod, nothing happens because it's at 0. So, but instead, if I bring it up to like 20%, for example, and then fill in the rest for the granola pod, you'll see when I push make my granola pod, it's going to start the motor. So in the context of the actual project, here, let me stop it 1 second. So in the context of the actual project, this doesn't really mean anything. It's just sort of demonstrating the connectivity between the front and the back end. But as a quick sort of visual demonstration of how I'm planning to program the actual firmware of the Unity boards and the Pi front end, back end, basically the front end would send the various carb, protein, fat percentages to the GranolaPods Python script. Our GranolaPods algorithm will change that into quantities of ingredients, and then what's going to happen is that there's going to be an i2c connection again between the Raspberry Pi and the Unity boards, and once it's finished processing on the algorithm, the i2c backend will start the motor, just again to demonstrate, will start the motor running, right? And now the gantry cart will be moving over along the rail until such a time when the magnet in the gantry cart moves next to the Hall sensor in the desired dispenser. And at that point, the motor will stop. Now the Hall sensor for the dispenser that's desired will have been continuously pulled by the i2c until such time when it reads the magnet next to it, and then it'll stop pulling it, and then it'll send a stop command to the Unity board on the gantry cart. Once it's stopped, it'll send an i2c command back to the dispenser to start dispensing, and then to stop dispensing, or maybe just to dispense a certain amount, and then the Unity board on the dispenser will decide how much to actually turn the motor. Once it's done that, it will send another signal to the gantry cart to continue the cart moving along again until such a time that it moves to the next dispenser, and the process repeats again.